Hi, and welcome in this session on FME with Snowflake. I'm Tom Levens and I will be presenting what's possible with FME with Snowflake. Together with me presenting will be Arjan Hijstek of Snowflake. He will be presenting what's the Snowflake platform, and Ivo de Liefde. He will show you some demos on what's possible with BI, GIS and data science in Snowflake together with FME. So what's on the agenda today? First, we will have an introduction on the Snowflake platform. Arjan will tell you how it works, what it is, and what's possible with it. Then we will see where Snowflake meets FME. Next, we will see that there is a challenge around geospatial data in Snowflake, where we can use FME to leverage that geospatial data. So we will explain a little bit on geospatial data and introduce the challenge. And then next we will show that with FME it's possible to get geospatial data into Snowflake and also to leverage that data with a demo on the public sector and a demo for the utilities. Then we will have a wrap up with FME and Snowflake, how does it work together, and then we will have time for a Q&A. But first I give the floor to Arjan for an introduction into Snowflake. The floor is yours, Arjan.
Thank you, Tom, and thanks for having me for this presentation about Snowflake. So thank you all for joining this session. My name is Arjan Hijstek. I'm one of the pre-sales at Snowflake. I'm based out of the Netherlands and I joined Snowflake last year's May, and I'm in the data business for around 30 years. So about Snowflake, what do we see at customers, right? Customers, they want to move to the cloud. They have all these on-premise and cloud systems. They want to connect all their data. And nowadays they have this ecosystem of products and solutions where different data types and different technologies are used to bring the data all together if they're doing it in the first place. So what happened here is that Snowflake, the founders of Snowflake, they are both from Oracle. They have a PhD in database management, and they saw the rise of the cloud. They saw the rise of the big data systems, and they thought, well, that's not what we want. We want to have a central set of data so that all the data can be used for all the different use cases and workloads. So that's why they went to Oracle and they said, we have to use the cloud. We have to bring all this data together. Can we? And the Oracle said no. So the founders, they quit Oracle, they started Snowflake, and here we are. We have this amazing platform where all the data can be combined together for analysis purposes, for data science, for all these different workloads. And it makes it all simple and easy to use. And that's kind of where Snowflake is. So a little bit further around Snowflake. What we now see at customers is they have all these data silos of data. So in the previous slide, with all the different technologies, even there, you always have these different data silos, not connected to each other. And that's what we as Snowflake want to enable customers to bring all that data together. And that's why we have Snowflake. So what is Snowflake? Snowflake, well, we do a lot more, but at the moment we have this cloud data platform. It runs on Google, it runs on Amazon, it runs on Azure. Of course, it can easily integrate with all the surrounding tools from these cloud vendors, but we are kind of agnostic for the cloud. And we allow these 6 different workloads. So that's for data science, data engineering, data lake, data sharing, and application building. And on the left side, you see all these different data sources. So you can bring all this data, for instance, with FME, into Snowflake for analysis, for data science, and for reporting use cases. In this case also, you see geospatial on the left. So geospatial data can also be brought onto the platform. But we do much more. So what is Snowflake? What is the architecture? So like I said, it runs on Google, it runs on Amazon, and it runs on Azure. In any of your regions, you control where you start Snowflake, where you do your workloads. You control, we don't. We just provide you this as a server, as a service, and you pay for use. That's also pretty unique at Snowflake. So when you have the data loaded into Snowflake, we use that data for all your different use cases and workloads. You don't have to copy the data. You don't have to bring in data out to other tools or whatever you. You can connect different tools, reporting, data science, ETL tools, FME in this case, to Snowflake. You can do that without any copy of the data and in a very easy way. Now in this picture you see the storage in the middle. So for that we simply use the storage provided by the cloud providers. So there's no proprietary hardware or from Snowflake. We just use the cloud provider's infrastructure. So for instance, Google Cloud Storage, S3 buckets on Amazon, and Azure AWS Gen 2 on Azure. And then we load the data and for your workloads. Second step is you want to use the data for your workloads, so you need compute resources. And these are the blue boxes in the middle. And a unique feature about this is that these compute resources are also provided by the cloud providers, but these are not interfering with each other. So what you now can do is have different workloads running separately, not interfering with each other, but going after the same data. And most important is the green half circle at the top. This is what we call the Snowflake brains, the cloud services where we have the transactionality, the SQL optimization in this platform. So think about this, cross-cloud, cross-region, one way of working in a very easy pay-for-use way. A little bit further on the infrastructure, how does it all work? So, in the middle, you see Snowflake with the Snowflake on Amazon, on Azure or Google. And then the surrounding radars, the clock wheels if you like, this is what we call the compute resources. Again, this is not from Snowflake, we are just using the infrastructure from the cloud providers. And these clock wheels, they can be of any size. So you can have an extra small, you can have a medium, you can have an extra large. We provision that within a second. That can be used for all your different workloads. And as you can see already, these go all after the same data, but these do not interfere with each other. So they are totally separated. So how can you use it? For instance, on the top left, you have your extra small compute and you do your ETL stuff or your ELT stuff. So like with FME or Informaticas or Warescapes, you just load the data into Snowflake. Or if you have a streaming use case where sensor data, IoT data comes in and you want to do it in a more streaming way, you can use the Kafkas of the world, the Naivais of this world, and to stream the data into Snowflake. And then on the right, you can use reporting tools where you can consume the data. And again, with a different compute resource, in this case an M, a medium-sized. And at the bottom, you see the data science tools, your Spark, the RStudios, the Python, Jupyter notebooks, and all different other data science tools which easily can connect to Snowflake, where the data still is just one single copy to allow you all these different use cases onto the Snowflake platform. And what we also can do is give you scalability. That's what we see in the field. Customers, in the past, they bought a Teradata box, they bought an Exadata box, they bought an Netezza box, and at some point, for instance, they have quite a lot of workloads, and at some point they want to add more, and this box is just overloaded, it cannot handle it anymore. We, from Snowflake, since we run on the cloud provider's infrastructure, we can scale kind of unlimitedly. So if you need more power, we just give you more power within a second. If you don't need it anymore, you simply switch it off and you don't pay for it anymore. Similarly, if you want to have more compute power for multi-concurrency, we allow you to simply scale out, give you the same compute multiple times, all within a second, so that you can provide your multi-concurrency aspects of data consumption. More important, what we also do on the top, we also now have something what we call the data cloud. So what we now see is all these customers, they really want to consume data from other data providers and or they want to monetize on their own data. So they want to provide their data onto, let's say, the Snowflake marketplace, where we allow that other Snowflake users or other users not even having Snowflake consume your data, and maybe they have to pay for that. We allow you to do so in a very easy way. That means you control the data, you still own the data, you update the data, but the second that you have updated the data, the consumers of the data will have that actual fresh live data. They don't have to copy it, it's just provided by our Snowflake marketplace. Now, more important, if you look at the data with all these cloud providers, we give you very easy ways of working with data. For instance, you want to clone your data for development, test and acceptance use cases. You want to really have replication features where we allow you to replicate between, let's say, Azure Netherlands and Amazon in Ireland, or Azure in the US, for instance. These are just a couple of clicks and we do that for you. Why? Customers, they might have a preference for, let's say, Azure, but at some point we now know at the moment Amazon is a little bit ahead from a data science perspective. So let's assume a customer says, I'd like to do my default work on Azure, but I want to do this data science and my machine learning stuff, I want to do that on Amazon. So we just replicate the data cross-cloud, cross-region in a very easy way. Still, it's your data, but then in the different region, you will do your data science workload on Amazon and off you go. This is how we help customers to go fast in a very easy, with a very low TCO platform. So what we now also do, I was talking about that already a little. We have this data cloud. And what we see is customers, they have their own data. They love their data, it's unique to them, it's very useful to them. But what if they could share the data with someone else? That could be an internal lines of business, that could be an external party, that could go via the marketplace for data monetization purposes. With the Snowflake Data Cloud, we allow you to do so. So this picture is really a live picture. We have thousands of customers. The single dots are simply customers just using Snowflake. The connected lines are customers sharing data with others. So think about where now all this data, IoT, sensor data in this case, geospatial data, your marketing data, depersonalized or not, comes available for a data sharing use case with maybe your supplier or maybe other customers. This is what we do with the data cloud. We allow you to very easily share data cross-cloud, cross-region. So how can you look at the data cloud? See yourself at the middle. You could be a single Snowflake customer, let's say on Azure in the Netherlands. Let's assume you have your direct vendors, your internal lines of business. This is the second circle you want to share your data with. You control who has access to it, if it's a subset or a data, if it's a secure view, the middle circle allow you to do so. And what if you want to share with external parties, not being your direct vendors, not being your customers? That is to be done on, let's say, the Snowflake marketplace in a very easy way. You control where, you control with who, you update the data, and once you are done, all of them have the latest actual data without the need for copying the data. It's a pretty powerful feature of Snowflake. So with that, we have Snowflake, and then we have FME, and FME here can load and extract the data from and to Snowflake. It can do all these geospatial manipulations and calculations so that that data can be stored in Snowflake and that the data can then be consumed, being it in a data science use case, in a data engineering use case, or in a reporting use case, as an example, or maybe in an application built with any of the application solution tools. So Tom, back to you. Thank you for having me.
Thank you, Arjan, for this introduction into Snowflake. So you now know what's all possible with the Snowflake platform. And you probably already know what's possible with FME. So you see where they meet each other. They both want to break down silos. FME as an ETL and Snowflake as a data platform. Together we can use the different capabilities of Snowflake and FME together to overcome a spatial data challenge. Let me get into that spatial data challenge. So we want to connect any data. That's also what was shown by Arjan. We want to have geography support, and there's already some geography support in Snowflake. But we also want to have geometry support and do a spatial analytics. But what's the difference between geography and geometry? We will explain that to you, and we also will show what the challenge is. Our challenge is the world is shaped in, let's say, a weird form. It's not really a perfect sphere. So that gives us some challenges when you want to put a point on a place. You want to say, okay, I'm here on this location, like with GPS coordinates. This weird form is because of the rotation of the Earth and also of gravity. That changes also over time. And like you can see, it's not a perfect sphere. So if you want to create a sphere out of it with a coordinate system like WGS 84, then you have some challenges, because some areas you will have a good fit, some areas you won't not have a good fit. That's also why we have regional coordinate systems. Think of NAD 83 for the United States, or like here in the Netherlands, where we are based, it can be the Amersfoort coordinate system. And there's another thing, because it's really hard to do analytics on a sphere. A coordinate system is not really useful for that. It's more easy to have something on a flat map and to do geometry on that. So remember, what we're talking about here is geography. And when we're talking about that flat map, which you most often see, then we're talking about geometry. Snowflake has support for WGS 84 in geography. But there is a challenge, because what if we want to have it in a different coordinate system? Or what if we want to do some spatial analytics on it with geometry? So geometry, you probably know it from your math classes. It's a way to calculate distances between points. And that's what we want to do on the map, right? And remember that geoid, that weird shaped sphere, what is our Earth? We want to get that on a flat map. And there are different ways to do that. Like you see examples over here. You can do it cylindrical, conic, azimuthal. It depends on where you are on the Earth to get a best fit, to get good calculations of your geometry, really exact calculations. And that's what we call projections. And you probably know Google Mercator from Google Maps, but you have also projections for local systems. So this is geometry, where you can do calculations of distance, but also other different kind of spatial analytics. And this is not yet supported in Snowflake. So that's our challenge. We want to get geometry data into Snowflake and also leverage that. And also have geography in other coordinate systems than WGS 84. So we came up with a solution for that. We did do a proof of concept together with Snowflake and Safe Software on this topic. We will show you today how you're able to use your GIS system or your BIM system to connect data into Snowflake, to get it in Snowflake with full spatial support, geography and geometry, to do also spatial analytics in Snowflake, and also get it out of Snowflake with native support. Think about your BI applications which already support WGS 84 and which can connect directly to Snowflake, like Tableau can, or with your Jupyter Notebook when you're doing data science. We will show you how we did do that. So we had some use cases. And of course, with this whole COVID-19 situation, we thought that should be interesting for many companies to do some analytics on it. So what we did do for the Netherlands is gathered some address data of hospitals, some administrative data of hospitalizations per municipality, added some municipality boundaries, so some geometries, and thought of ourselves which areas could benefit from a field hospital because of COVID-19. This would be a question you could ask yourself when you're in an organization in the public sector. And you want probably to create something in a BI system and visualize it over there so you can report it. We did do this with FME as integration, with Tableau for visualization, and of course a Snowflake as data platform. Ivo will show you how we did do this.
Yeah, thank you, Tom. Yeah, here in front of me I have a Jupyter environment that is connected to Snowflake. It's one of the nice things about the Snowflake environment is that you can easily use Python to connect to your instances. So here in the first couple cells you see that we create a connection using Python to our Snowflake demo environment. And with this connection we can basically access everything that we want to do in Snowflake from our Jupyter environment here. So that's what we're going to use for this demo. One of the first functionalities that we would like to show to you is called Geocoding. So for most of the FME specialists in the call today, that will be a familiar topic. But just as a quick reminder, if you have any address information, then you can use the concept of geocoding to create a coordinate for this address. So if you just have the textual information of the location, street name, zip code, all these kind of information that you can possibly have in your tabular data, you can use geocoding to transform this to a point that you can place on the map. Yeah, and this is functionality that's not available in Snowflake natively, but using our FME integration, we added a functionality to perform geocoding. And let me just run my notebook cells to show you how this works. So we can do a select, call our geocoding function, which triggers FME server. And then once it returns, it will give us a point coordinate for this specific address. And in Python, we can also plot this on the map. So in this case, you can see that the address that we put in is actually placed here on the map in the Netherlands. So yeah, that's geocoding. We've used FME to perform this task in Snowflake, and we also use this for the next demo that we will show in Tableau. Yeah, so we've seen how we can perform geocoding in Snowflake using FME for the spatial component of this task. And here in front of us we have a Tableau dashboard, and this Tableau dashboard connects directly to Snowflake and pulls the data in both tabular and spatial data. So what we can see, for example, is that we have our municipalities here, and all these orange dots are geocoded hospital locations. So from an Excel file with address information, FME transformed this to geometries, and now we can show this here in a Tableau dashboard on the map as well. And the nice thing about this is that you can now use all the spatial functionality that you have in a BI application such as Tableau on your Snowflake data. So for example, we can make these kind of spatial selections now, and then all your graphs will update dynamically based on the spatial component of your data. So that's how we can integrate Snowflake and FME to create better BI dashboarding.
So, thank you Ivo for showing this demo. You saw how we did get data into Snowflake, geospatial data, and also how we were able to leverage it directly with Tableau from Snowflake. But this was not the most complex geospatial data. So we wanted to challenge ourselves a bit more. So we thought of a scenario where we have wind turbines on sea, which were inspected by a drone. Those wind turbines are in a strange coordinate system, so to speak. We're talking about a coordinate system specific for the North Sea near to the Netherlands. And we want to again visualize that, but this time not only in a BI system, but we also want to visualize it in a GIS system, in ArcGIS Online. Ivo will show you that you can upload some data with FME server from a drone and sync that via Snowflake into ArcGIS Online. Here's to you, Ivo.
Yeah, thank you, Tom. Then we'll move on to the second demo. Yeah, so the session here, of course, is hosted from Vancouver. So here on the map, we are looking at Vancouver right now. But our presentation is hosted from the Netherlands. So let me just slide over to the Netherlands. And yeah, the Netherlands, you might know it from the old windmills. But nowadays we also have some windmill parks with the modern types of windmills, the wind turbines. And that's what the second demo is about. So let me just zoom in to one of these locations and we can tilt our view a bit. Yeah, so in the North Sea, in front of the Netherlands, we have a couple of wind turbine parks. And yeah, these wind turbines, they require regular maintenance. And one of the ways to perform this maintenance is to do drone inspections. And that's what we will take a look at in this demo, to see how you can upload drone inspection data into Snowflake using FME. So yeah, let's go ahead and do that. If I go to the FME server application, then I can just drag and drop our GPX file with the drone flight locations into FME server. Press OK. And what's happening now is that FME is uploading this file. It's performing a reprojection into the North Sea coordinate system and it stores this in Snowflake. Yeah, so it's completed now, which means it's has been uploaded. Can be used in Snowflake SQL at the moment. But one of the nice things about using FME in the Snowflake environment is that we can also perform all kinds of synchronizations with this data. So the next FME app that we will show you here is it's just a simple button, a trigger. You can also configure this trigger to run automatically if there's a new upload, or to have all kinds of triggers that you can automate in FME, of course. But for the purpose of this demo, we do it with the press of a button. So if I press this button, FME will look at our Snowflake demo database, retrieve the data that we just uploaded there, and synchronize it with our ArcGIS Online environment. So as we can see, it's completed. So let's go back to our map here and see if it shows the drone points now. Yes, and as we can see, we now have all these orange dots, which are the recorded locations of the drone that did the inspections. And based on these locations, you can determine which images are about which wind turbine, and also we can calculate what the distance is to the wind turbine to get the best image for specific parts of the windmill park. So this is one of the ways that you could use FME. You can use it for doing reprojections, for synchronization. But let me switch over now to our Jupyter environment, and then we can see what actually happened in the background. So with FME, we've created a functionality in Snowflake which does reprojections. So in the previous demo, we saw a functionality that did geocoding. This works in a similar way. It's a SQL function that we can call. And here we see that it's reproject from to. And if you just give the original coordinate system, you provide the coordinate system where you want to transform it to, then we can run this and perform perform any transformation, any reprojection that you could possibly want. So now it performed a reprojection on some of our data, and if we take a look at what that looks like, we can see that the coordinates have been changed, even though it's the same place on Earth. It's just in a different system, so it has different coordinate values here. So that's what we've implemented in Snowflake, and you can leverage all the reprojections that FME can possibly perform from Snowflake as well. Yeah, so the next part of this demo is to take a look at how you can use the Snowflake API to query data directly into your data science environment. So one of the very popular packages for data science is called Pandas. It's a data frame. It's a package for data frames in Python. Very popular in the data science world. And it's really nice with Snowflake that you can just query your Snowflake demo database directly into Python Pandas data frames and use that for your analysis. So here in this cell, we see that we can create a SQL alchemy engine and perform a query on the windmill, the wind turbine parks dataset. So we have all the polygon shapes of the wind turbine parks. And at the moment it's still textual character string, the geometry, because that's how FME stores it in Snowflake. Could also be binary, of course, but for visualization purposes, it's easier to see that we have a character string with the geometry in there. And this kind of data is now reprojected into the proper system for the North Sea. And as Tom mentioned earlier, it's important to use the right coordinate system for the right type of job that you want to do. Going from a three-dimensional Earth to a two-dimensional plane is something that you cannot do without distortion. So this is a very nice visualization of where these distortions are introduced. So everywhere where you have this cut here in this globe that we try to make two-dimensional, we introduce distortion, and depending on where you want to perform your analysis and what kind of analysis you want to do, you want to select which kind of system fits that purpose. Because we want to prevent creating mistakes due to the incorrect system. So if we want to calculate the distance, for example, between two cities on different continents, you don't want to draw a straight line if that's actually a distorted representation of the shortest distance between these two areas, because the actual distance would go like the curved line that we see here on the top. So these kind of errors we want to prevent, so that's why it's important to use the right system which FME can generate for you. So in this next step we use a package called GeoPandas and Shapely to create geometry data type based on the the data that FME stored in Snowflake. And with this data type, we can perform the actual geospatial analysis that we want to do. So as you can see, we now have a nicely formatted geometry column there. And if I plot this data, then we can immediately see that these are not just the character strings that we're plotting, but that we're plotting the actual geometry. So these are the areas of the wind turbine parks. And if we want to perform analysis on this, so let's start with performing an area analysis. How big are these areas? Then we can immediately see that if we do this in the system that's natively supported by Snowflake, that this is not really the way to go. Because if you want to calculate areas in WGS84, then Python will immediately give you a warning telling you, okay, don't do these kind of operations in a geographic CRS. The results are likely incorrect. But if we do the same analysis with the reprojected data that FME provided for us, then we don't get this error message and we just get the information that we want to retrieve. And with this geometry data type, we can now do all the analysis that you would possibly want to do. In this case from Python. Could also do it from other GIS applications that you prefer to use. And just an example of what you can do. Let's say that we want to have the shortest distance between two wind turbine parks. You could, of course, take center points of the parks, draw a straight line between those. But that's usually not the shortest distance because you want to calculate that from edge to edge. So in order to calculate what the shortest points are between these two areas and to draw the shortest line between them, we can use some Python packages. And they work with geometry data types. And yeah, so that's what we've done here. So these two orange dots are the locations that are nearest to each other. If we draw a little circle around it, you can also see that the orange line is in fact the shortest distance between these two areas. Yeah, so that's basically what we can do with Snowflake using FME in the background, and also using our Python API from Snowflake to do that from a Jupyter environment. Yeah, and this shows you how you can use FME for all your geospatial functionality inside Snowflake on the fly. So let's get back to the main story, Tom.
Thank you, Ivo, for your demo. So now looking again to this architecture diagram. You saw what we proved to you. So we used BI applications to directly connect to Snowflake, to that native support with WGS84. But first we added data into Snowflake, which was not geography, but geometry, or geography with another coordinate system with WGS84. And that's all made possible with FME. And in Snowflake, we can trigger FME to do analysis, to geocode, to transform data. And of course, you can still use also FME to connect to Snowflake when there's not yet native support for Snowflake, like for ArcGIS Online or ArcGIS Enterprise. It also could be any other GIS or BIM system. So when you already have FME and you are thinking of a data platform in the cloud, which is unique, which is Snowflake is providing to you, Snowflake and FME together can give you full spatial support. So Tenzing can help you on that topic to get that data in and to get rid of all your silos. So the takeaways what should you remember from this session? That Snowflake is a really powerful platform for data storage, processing and analytics. And it's available on AWS, Azure and the Google Cloud. Snowflake supports essential geographic functionality. You can consume it with any tool and share it with everyone. Like also Arjan mentioned, the data platform, which also makes data available. And our proof of concept, together with Snowflake and Safe Software, shows that FME can be used, integrated in Snowflake to enable full geography and geometry support. So it breaks down spatial silos together, connecting any data with full geography support, full geometry support, enabling you to do spatial analytics, either with FME, but also it could be with Jupyter Notebooks or other tools which you have available. So probably you have some questions for us. We shared a lot with you. Maybe some things were new, maybe you did not yet know Snowflake as a platform. Maybe you are wondering, how did we do that? How did we do this integration? And maybe you want to know more. So please come to our live Q&A, and also you can meet us at our booth. Thank you.